Yes. Okay, we are live.
Hello. Oh, but
What happened?
Hello, I warmly welcome you to September. I'm really delighted that you have come to join us. Our today's special guest is Dr. Peter Weiss.
Hello.
He is space artist, engineer, and member of the IAAA. Peter?
Yes, I had a little bit interruption, so I hope you did well presentation. Shall I share my screen?
Well, maybe I want also to welcome you, if that's fine. If you can hear me. Yes.
I can hear you.
Yeah, I can hear you.
I think, Sabine, you are having some problems of connection. Yeah, technical problems always.
Can you hear me well? We have technical problems, I guess. Can you hear me now?
Yeah, we can hear you now.
Yes, okay, then I have to go to my corridor. Our today's topic is, I'm sorry that the internet in Germany is not the best. Our today's topic is Spartan Space and Europe Moon Habitat and how it can help to address challenges on planet Earth. And I also would like to welcome our president, Bernard Foying. Hello, Bernard.
Hello, so it's a pleasure. Here I am from Milano, and we were in Padova, and we were also in Torino, where actually we deployed a moon habitat in the botanical garden, and we had a demonstration. We had more than 1,000 visitors that came to see it. And today we had also an event close to the new airport where we are going to organize a number of events where we are going to connect between habitat and even parabolic flight and other astronaut training facilities. I had a big pleasure to know Peter Weiss, because actually he was my host, and he showed me. He showed me the COMEX at the time when he was working there, and we had a great visit also with some colleagues of the COMEX Center, you know, the Center for Divers, which is I also use for training of space astronauts. But now he went on his enterprise with the Spartan Space, and we have been also trying to collaborate on Spartan Space. So clearly, it's a great mixture of the drive for exploration and also entrepreneurship, and a good connection also with some of the possible stakeholders that are going to go with us. So actually, Peter could be an ambassador of Space for All, because he's acting for Space for All on Earth and beyond. So thank you, welcome, Peter.
Thank you,
very much,
Bernard. Thank you. I also would like to introduce Adriano Ottino. He's also a vice president of Space Renaissance International, former president and one of the founders of SRI. Hello, Adriano. Welcome.
Thank you, Sabine, and very welcome to Peter and to Bernard here for this very interesting webinar that I'm quite curious to attend. And yes, we are back from New York 2 days, because we were at the UN quarter where we had a historical meeting about the proposal of an 18 SDG focused on space development. And yeah, the title is A Space for All on Earth and Beyond. We have now 61 organizations called allied to support this proposal. And yeah, later I will put the proper links in order everybody here can sign the petition and to maybe add their organizations or companies in the alliance. So, however, yeah, very welcome, Peter, and let's listen to your presentation. Yeah.
Sorry, oh, sorry.
Okay.
Do you need a glass? Or?
Yeah, I have it, but there is no internet connection. Sorry. I'm sorry. I wanted to introduce our guest. I have to apologize. The Artemis program will open a new era of exploration, space exploration, and a beginning of a sustainable presence and exploration of the lunar surface. The moon is not a stepping stone toward Mars, it is the stepping stone. And the target of the mission is a lunar south pole due to strategic resources that will be needed to set up a sustainable presence on the moon's surface and to prepare toward destinations such as planet Mars. But one must understand that the region of interest has approximately the size of the city of Paris, so it will be crowded up there. To Peter Weiss, I would like to say Dr. Peter Weiss will present Artemis not only from a European perspective, but also from the point of view of one of the startups in Europe's space sector that are targeting the moon. What could be an European contribution to Artemis complementary to the US space program? Spartan Space, you will think, I think you will talk about this a little bit more. Spartan Space from Marseille, France, works with its industrial and agency partners in Europe on the development of a secondary habitat, EuroHub, which can be brought to the lunar surface by European capacities. It can serve as base camp for extended extravehicular activities of Artemis crews and might become a rallying point between different robotic and human missions. Dr. Peter Weiss will present this concept and illustrate its development since 2021 by Spartan Space. He will also show the industrial challenge and its business model, which is based on the return of technologies to terrestrial applications. Dr. Peter Weiss studied engineering in Germany and France and did his PhD at Hong Kong Polytechnic University. And he is founder and CIO of Spartan Space Marseille in France, and he has more than 20 years of experience in the management of industrial and research projects in maritime and space sectors. He was awarded with several prizes, and and we are really curious to listen to your lecture, the floor is yours.
Thank you very much, Sabine. I hope it's getting better. Thank you, Bernard. Thank you, Adriano. So I share my screen. You please let me know if this is working. Can you see my screen?
Yes.
It's coming.
Excellent. Okay, so thank you very much for inviting me today. I'm very honored being part of this lecture series. So as Sabine presented already or said already, I'm going to talk about the development of a habitat for the moon, for Artemis, a European habitat that we are proposing to these Artemis missions. But I want to go a little bit further, not only talk about this challenge, but also talk about how technologies coming out of this this kind of development can help to address certain problems that we have on Earth right now. As Sabine already presented, so I'm CEO and one of the founders of Spartan Space. Spartan Space is a very young company. We are a little bit more than 2 years old, and we want to work on habitation systems for extreme environment. Might it be space, but we are also working in other fields that I will present that a little bit more in detail. So what we are interested in is on technologies that help people live and work in extreme environments like the moon, for example. Sabine already presented a little bit my curriculum. I'm a roboticist originally, so I've been working at DLR at MIT, and I did a PhD in Hong Kong Polytechnic University in space robotics. I also worked a long time in underwater robotics. So first of all, I very much like the link between space and sea, and that is also reflected in my career. But albeit I'm a roboticist, I'm very much in favor of human spaceflight. I think human spaceflight is extremely important. It's important to extend the frontiers of human civilization. So this is really part of what we want to do, part of our vision. So as I said, Spartan Space is a very young company. We have been founded with a team of engineers, astronauts, and architects. We are already working on several projects. Some of them are just mentioned here. So in the field of space, we have the honor to work with Thales Alenia Space in Torino and Liquifer on iHub, on the development of one of the European modules for the future space station gateway. We also work with Liquifer and Airbus on another concept on an commercial orbital station that was an ESA project that just finished. But as I said, we are always swimming between both areas, space and sea. We also have some projects underwater, if I might say, like an underwater station that you can see here on the upper left, that is developed currently by an explorer, a French explorer called Alban Michon, for whom we are working in order to do the engineering. We also work with a very famous architect in France, Jacques Rougerie, who is working on a concept of a subsea city that hopefully will become reality in some years, and allowing also people to live and work underwater. Before explaining more in detail EuroHub and why we came up with that concept, I would like to explain the context of space exploration. I will not go very much in detail because I think that most of the people here are already aware about what's going on in Artemis, but I think it's important to show a little bit what are the coming steps in space exploration, and then also put our habitat concept inside this development. So as it already was mentioned a little bit by Sabine, there's a question that could be asked: what is the next step in space exploration or human space exploration? Is it the moon? Shall we first go back to the moon and then use the moon as a stepping stone towards Mars, or go directly to Mars? Obviously, if you have read the introduction, I am in favor of this first strategy, first going to the moon and use the moon to go further. Sometimes you can hear people saying, okay, why go back to the moon? Let's go directly to Mars. I must say, I find that a little bit nonsense, and I'm actually quite shocked when I hear that from people even coming from the agency, because we have to be clear, today we are not we don't have the capacity to go to Mars. Neither in terms of technology, neither in terms of budget. This is not possible. We first have to establish a sustainable presence on the lunar surface and then use that to go further. And I would also say that any nation that is not involved in lunar activity will most probably not be play a significant role in missions to Mars. So that is why it's so important to go to the moon. And as it was already said before, I will present my point of view as European in this whole challenge, because obviously I think that Europe has to play an important role in lunar missions next to its international partners. So first the moon, then Mars, and not directly Mars. I don't think this would work. And I'm not alone with that opinion, obviously. There's the Artemis mission that most of you might have heard of. So the follow-up of Apollo, humanity's return to the moon, initiated by the US, by NASA. I would like to go through Artemis very quickly, just in order, as I said, to explain why we came up with this concept of a secondary habitat Europe. So Artemis, you might have seen that some months ago. Artemis 1 returned to the moon, not landing but turning around with Orion and the European Service Module. A very nice mission, a very successful mission. So the idea was just turn around the moon, not going to the surface. There will be Artemis 2 coming in some time. This will be the same thing, but with astronauts on board. Now one can say, and I was know already, okay, going to the moon is quite easy. The distance, the mean distance is 380,000 kilometers. So if you have that here on the screen, that seems very, very simple. Screen here, you have the whole thing in scale, and then you realize maybe a little bit more how complicated that is. 31 Earths that you can put in between Earth and the moon, and that shows a little bit the difficulty of going to the moon. It's really, really a challenge, and it's really a much further step than orbital missions like we do it today. Another comparison quite interesting: if you would go to the moon with a car running or driving at 80 kilometers per hour, it would take 6.5 months of travel. So the next step is going to be the Lunar Gateway. I already mentioned that. We have the honor to work with Thales Alenia Space on this. This will be an orbital station in lunar orbit, turning around the moon, not in an orbit as it is shown here on the screen. It's much more complicated. I must say I'm a big fan of Gateway, because Gateway is going to teach us how to go further beyond the moon. We are in quite a harsh environment already with the astronauts. So this will be the station that will teach us how to go to planet Mars, for example. Not to the surface, but to Mars, to transfer to Mars. So this is a very important step in my point of view. This schematics here shows the gateway. So it's a little bit like an international space station, like the ISS we have today. The schematics that we have here is a little bit old. Some of the elements might have changed. For example, the crew airlock, which was supposed to be developed by Russia. I suppose it's not Russia anymore. But it's still an international station with elements from ESA, from NASA, from JAXA, and from the Canadians, and maybe other partners in the future. So we work together with Thales on the module that you can see here right in the middle. It's the habitation, one of the habitation modules. And as said, it's Thales who is building these models. By the way, both of them, there are two European models. There's Esprit and IHA. Both are done by Thales Alenia Space. What's then the next step? The next point is going to the surface. And here I need to mention, and that's quite important, the European Large Logistic Lander, EL3. It's also called Argonaut. That's the vehicle that you can see here as mock-up on the screen. This EL3 is going to be a little bit the workhorse for Europe to bring equipment to the surface. It's like a transporter that allows to bring around 1.5, maybe 2 tons to the cargo to the surface. And that is extremely important in terms of sovereignty, of course, because it allows European instruments to be on the surface. and also to contribute something to international missions like Artemis. I must say I'm not a big fan of the picture that you have here, because if you compare EL3 with the capacity of the American landers, which is much higher in terms of mass, it does not really make sense that the European robotic lander will bring elements like a rover or food to the surface, simply because that thing will be landing quite far away from the human landing site, simply in order to assure the security of the astronauts, avoiding that both vehicles crash one into another. So if that thing is some kilometer away from the human landing system where the astronauts will be arriving with, then it doesn't make sense that those guys are walking to this vehicle in order to recover the rover that they are doing here on the picture. So we have to find other ways to use EL3, and obviously I have an idea about that, and will be the rest of my talk. But EL3 is very important. We need that vehicle. Europe needs that vehicle. Artemis is in preparation. This is the team or the selection of astronauts in the US that have been chosen for the Artemis missions. I very much hope as European that also European colleagues will join that team and that we will see a European on the surface, because Europe is the continent of explorers, and it would be a shame if we are not part of that. I mean, right now we have Indian missions on the moon, Chinese missions, of course, Japanese missions are coming, and many other nations. It's just not possible that Europe is not part of that environment. This graphic shows a little bit the overview of this whole concept of missions and the strategy of missions to come in the years until 2030, 2031. I try to make it a little bit more simple. So Artemis 1 flew some months ago in 2022. First flight of the SLS with Orion. Now Artemis 2 is coming in 2024. That will be also HLS and spaceship, not going on the surface. On the surface, astronauts will be going in 2025 with Artemis 3. So this will be 2 astronauts for approximately a stay of 6.5 days. Yeah, by the way, Artemis 2 might be 2 Americans and a Canadian. Most probably, I suppose, the first mission on the lunar surface after Apollo will again be 2 Americans. And this is then going on like that. We have then Artemis 4 coming, and Artemis 5. Artemis 4 will only be in orbit as far as it's foreseen today. Will bring IHAB to the surface, and then Artemis 5 will be again on the surface. We don't know how many astronauts. We don't know how many days. What I said today, it's going to be with a lunar terrain vehicle at LTV, so a little car that they can be driving around. And then until 2030, we have Artemis 6. Again, we don't know how many astronauts, how much time they will be staying there, but these, Artemis 6 in 2030. And from that point on, Artemis 7, 8, and 9 are not defined. And if I'm not wrong, not financed. And that's what I call the Artemis horizon. That basically means anything after 2030 is really not clear. And if Europe wants to play a role inside Artemis, we actually have to be very quickly, because this is going to be in 7 years. And people have to realize that. Well, there's a lot of discussion about, will this timeline be kept? Yes, sure, there will be certainly a little bit of shift, but I do not think too much. I do think that in very few years, we will see American astronauts on the lunar surface, simply because there's again a race between the US and China this time, and that dictates the timeline. So there will be astronauts in very few years on the lunar surface. And again, if Europe wants to play a role in there, we have to speed up. We have to find our place and our contribution. The schema shows the landing sites of Artemis 3. I won't go into detail into that. So it's all located around the South Pole. That is very important. It's quite particular. Some of the sites on the far side, those on the bottom of the screen. I find some of them quite curious because also there are some sites that are on high, quite difficult terrain with high slopes. I'm wondering what will be the final site. How far will it be from the South Pole, which is the dot here in the middle? Will it be on the far side, or will it be will it be on sites that are rather safe for landing? I also like to draw a little bit of a comparison between Artemis and Apollo, because I think this is very important. So Apollo was targeting several sites, many different sites on the lunar surface, all on the near side, of course. I think the closest one between one and two Apollo sites was around 160 kilometers. So there was no real interaction between both. Artemis is different. Artemis will be all targeting the lunar South Pole. And this is super important because that means that equipment that's brought on the surface by one mission can potentially be used by another mission. This will be also important when we are talking about the concept of the habitat that I will present later. For Apollo, the primary objective was geologic exploration. That's why they were choosing different sites quite far away. For Artemis, the primary objective needs to be sustainable presence. As I said, we should not redo Apollo if we have to build up something on the lunar surface in order to go further towards Mars ultimately. And obviously, Apollo was US only, more or less, while Artemis is a real international cooperation initiated by the United States, of course, the United States inviting, and that is a great thing. It's really a return of humanity to the lunar South Pole. Again, obviously, I already mentioned, I mean, you can call it as you want. There is again a space race between the US and China. There was this announcement during the GLEX in St. Petersburg 2 years ago about this cooperation between China and Roscosmos. I'm not sure at what stage they are now, especially with the crisis in Ukraine, but there is this competition, and I would not only see that negative. I actually, there are positive aspects because that will dictate a timeline to the whole thing. And Europe should stick to the US. That's my opinion. So what could Europe contribute here? First of all, I think Europe needs to contribute something complementary to Artemis. There is a lot of discussion about sovereignty in human spaceflight in Europe today. This is very good. I think Europe should be able to launch its own astronauts, but in order to fit into Artemis, we need to bring in complementary elements. We cannot just say we do exactly the same thing. That doesn't make sense. So what I call here a lunar logistics, it could be part of a lunar economy that includes many parts like the landing capacity, like the EL3 Argonaut or the Nix from the exploration company, rovers like the EMMS, power generation, that's a concept that's under development. It's a charging station using solar panels as a project going on. Secondary habitat like EuroHub, this is the thing I'm going to talk about the rest of my presentation. Then we have also in situ resource utilization with an initiative called Euro2Moon, and hopefully in the future large-scale habitats. And I would be very happy if this is a lot of little EuroHubs, of course. And I should not forget, there's also this navigation and communication capacity through moonlight, which is actually a quite advanced concept already. This is under development. So this is what Europe could bring into Artemis in order to help the US and other international partners to set up a sustainable presence on the lunar surface. And here I jump into my subject, the development of EuroHub as a secondary habitat. What is this exactly? A secondary habitat is a habitat that is brought by the robotic lander on the lunar surface It can be landed on sites that are a little bit more risky because it's landed robotically, so nobody is on board, there's no astronaut on board. And by doing this, you can extend the EVA, the extravehicular activity range of the astronaut. An astronaut can go with an unpressurized vehicle around 10 kilometers away from its landing spot, from a safe haven. 10 kilometers is the circle that you see around the HLS here in the video. If I place now a Eurohub, a secondary habitat on the right spot, then I can extend that distance to 30 kilometers. Instead of 10 kilometers, they can go 30 kilometers away. Now, what you see here on the chart is the lunar South Pole. What is shown are safe landing sites. These are these blue spots. I didn't invent it. We took that from NASA charts. These are sites that are very flat with low slopes. And then you have sites of interest, like the interior of the crater, where there's permanently shadow, and there might be water ice. So that's super interesting. And then also very nice, these yellow spots, which are peaks of eternal light, meaning on the South Pole you have regions where there's a lot of sunlight over the lunar day and night cycle. So these are the sites that are of interest. Now, if you see these blue sites where Artemis might be landing, they are too far away to reach these sites of interest. So they need a secondary habitat, and that's the idea of Eurohub. So we came up with that system. It's composed of two elements: one landing vehicle that you can see here. Here in this case, it's the European Large Logistic Lander, the EL3 Argonaut. But that is my transporter. I can come with that, or I can come with an exploration company, Nix, or maybe with another vehicle. This is my post office. This is a service I will just use. What we are developing is the payload on top of it, which is here an inflatable habitat that we call Eurohub. And that could be a European contribution to Artemis. So it could be landing on a spot prior to the arrival of the astronauts and be used as a base for the astronauts. So here's a little video that shows the concept. So we developed an inflatable habitat. Having said, we are not intending to develop ourselves this technology. We are searching for partners that can develop for us the inflatable system. And that's just an example. We search for many other subsystems that can be brought outside. Spartan Space does not intend to build all by itself. So the habitat arrives without astronauts on the surface, inflates, is getting ready. This is all happening robotically, nobody aboard, and it's waiting for the astronauts to arrive. And the astronauts will be very much later. As you can see, it can be landed on a spot that is much more risky than you would tend with a human system. And here we have our astronauts arriving from the human landing system, the big spaceship you can see behind, and they can then use Eurohub as outpost. As I said, they can basically triple their distance of intervention by having that habitat. By the way, obviously, technically, an astronaut can go much further than 10 kilometers with a pressurized rover. By the way, it's 2 kilometers by foot. But this is a distance of security. This is a distance that was calculated by NASA in order to have the security to bring them back if ever there's a problem. Eurohub will not only serve, and I'll talk a little bit more about that later, for astronauts. It can also be a rally point for rovers to bring samples to this habitat that can then later be collected by astronauts. So the idea is really building up something sustainable on the lunar surface. And as I said, what is very important for us is that we fit into the payload capacity of the lander. There are many different concepts of habitation systems on the lunar surface. They are all wonderful, they look great. But the problem is, if we do not develop a habitat that can be brought technically on the lunar surface, then this is science fiction. Really need have to something that can be brought by a robotic lab. So here again, the concept, and I'm sorry, there will be a little bit of French in the coming slides, but I hope you nevertheless get the idea. So the concept of the secondary habitat is an astronaut can go 10 kilometers away if he or she has a rover from the safe landing point. If I have a habitat placed on the right position, it could be approximately 30 kilometers. Meaning, in the case of a problem, they can go back to the habitat. If there's a problem with the spacesuit, they can go back to the habitat, and they extend their intervention range. So, place that around Shackleton crater. This is very interesting because I could land my habitat on one spot while the astronauts arriving on another spot. Here, I took one of the famous Artemis 3 landing sites. So these astronauts could use the habitat as a base in order to go further, maybe go inside the crater. It can be used as a handover place between one and another Artemis mission. So the astronauts could leave some equipment in EuroHub and it is be recovered and reused by another crew coming later. Or as shown here in number 2, I could have a robotic vehicle that is simply bringing stuff to EuroHub, might be samples, in order that they can be recovered by a next mission. The habitat will be staying there. It's not moving around. It will be staying there. It will be the first permanent settlement on another terrestrial body. So we came up with that concept right away from the beginning of the company, and we had the chance to build a first prototype that was exposed at the IAC in Dubai. That's a picture you can see above here on the left side. Thanks to funding we got from many different entities, including ESA and CNES. We also did then some trials, analog trials in Abu Dhabi. Since we were in the region, we profited from that and did some trials with that habitat. Then it came back to Europe, and it was part of a rover challenge in Luxembourg, where you can see here some photographs. By the way, that gives you also an impression of the size of the habitat. It's approximately, that version is 7 meter high, 7 meter in diameter. And that was a real nice challenge. I have a video here where you can see my food, and that shows you a little bit the environment that was built up here by the colleagues in Luxembourg and the European Space Agency. Like on the moon, my colleagues forget to put the spacesuit, so that I filmed them while they were repairing something. And we used these trials in order to make some tests with rovers. We were testing several things like night survival, resupplying the habitat with oxygen, and also sample delivery by a robotic vehicle. So that was a very nice mission. And I show you a second video here that was then done with the association Euro to Moon with different partners. So the idea was to simulate the resupply of the habitat with oxygen. We do not want to build a throwaway habitat. Our habitat needs to live over several missions. And in order to do that, we need to resupply it with oxygen. So we worked with different partners. So we had an oxygen generator by Airbus, a little rover by iSpace. We worked with Air Liquide on fuel cells. I'll talk about it a little bit more in detail. Then obviously we had EuroHub and DL3. And the idea was to simulate in a very simple simulation how a rover, a small rover, it was a very small system here, could transport oxygen from the oxygen generation plant of Airbus to the habitat via a docking station that we were developing. These were non-functional trials. These were really only ergonomic trials, but already to identify a little bit the different partners and technologies needed for that. So our robot was doing his job, driving to the habitat, and then docking to the docking station. I let you watch the video. By the way, these trials took place approximately 1 year ago. ESRIC and ESA built up a large terrain that you can see here, size of a stadium more or less, that was used for rover trials. This was a real nice simulation. This in a terrain like that. So our rover was docking to this habitat, and then virtually transferring oxygen to the habitat. We are improving this now. We continue working on the docking station because for us this is a primordial element. It is needed to supply the habitat with gases or with energy, but can also serve to connect a rover for night survival. So we really want to push that further. So I said we're working on that. We are working on that with the CEA in France and Air Liquide. So we are developing a mixture between an energy management system and life support based on regenerative fuel cells that can be used. Actually, it's quite nice because we use flexible solar cells from CEA in order to pump energy into the fuel cell, and the fuel cell can then be used to create. It's a regenerative fuel cell, so we create hydrogen and oxygen, which can partly be used by the life support system, and then be burned back, and then we get out water. So it's actually quite a nice mixture. It's not as easy like that, but the different elements of interest are there, so we want to use that. Also, another aspect is the way energy will be consumed in that habitat. This habitat will only be used for very short moments in time when a crew is there. Obviously, some energy will be used all the time, but most energy will be used when the crew is there. So we have a lot of time to load to charge our habitat with batteries or fuel cell. Then we burn it down very quickly when the crew is there, and then we have again a lot of time to charge it up. So actually, we are not interested so much in energy production. We are more interested in energy storage. That is the reason also why we are working on this kind of system. We also performed with the help of RST-ARC, which is a very nice network of architects for extreme environment, and L'École Commando, which is an architect school, different studies on the interior of the habitat. You can see it a little bit here. The students came up with different design concepts, very nice, how EuroHub could look inside. As I said before, we want to use that habitat as a science station. Even if there's no astronaut on board, it is there all the time and can be used for science. And so we are working with different entities, especially with the IRAP in Toulouse, on how this could be developed. So not only docking station for robotics, but also the possibility of measurements of the exosphere, spectroscopy. We also want to potentially in the future upgrade it with a seismometer and surface science, and more importantly, a sample collection analysis facility. I come to this point in a second. The habitat will be communicating obviously with a system like Moonlight, for example, and can also be used as a navigation relay in proximity so that astronauts can navigate around. As said, so we're working with a team in IRAP on sample collection and storage. The idea is that astronauts and robots can bring samples to EuroHub, where they can be analyzed either by an astronaut or robotically through telescience. And this is quite useful because that could, especially at the beginning, help to select really samples that we would like to bring back to Earth if we do not have the capacity to bring back everything. So there could be a selection being done in situ on the surface. We also, and this concept we are now driving further. We want to go into a prototype development. We also used the trials in Luxembourg to play a little bit around on, if I might say, robotic ergonomics, how samples can be offloaded by a rover. So we had different candidates here that were playing around with our system. The idea is having something like a lift here. So the robot is unloading a sample here, and then the sample can be lifted up into the habitat robotically, where it can wait for an astronaut to arrive. So after the Luxembourg trials, we went to the European Astronaut Center, where we had the possibility to present the habitat to the high-level advisory group, the HILAC in Europe. This is a group that was set up, I think, under French initiative by ESA to define European space policy and strategy. So we presented EuroHub to them. We also had the chance to expose our habitat at the ministerial conference of ESA in November last year. Unfortunately, it was just a small mock-up, the same that we had exposed in Dubai in the Universal Exposition. And then we had the chance to go further with that with two other partners, if I might say, with CNES, financed by CNES, and Thales Alenia Space. We were working on a concept that is called LEAS, which stands for Lunar Integrated Shelter for Exploration. But it's quite the same like EuroHub, if I might say. So in LEAS, we had the chance to dive into all subsystems. Also, we had to review the geometry. As you can remember, our first habitat was 7 meter in diameter, 7 meter high total. It was quite reduced. Now it's 4 meter in diameter, 4 meter high. Why? Because we had to review the mass budget of that habitat. As I said before, if we cannot fit that onto a landing system, a robotic landing system, then this is science fiction. There are many nice habitat concepts, big domes, and large infrastructure on the lunar surface. Unless somebody is explaining to me how these things will be brought with today means on the lunar surface, this is science fiction, and I don't want to make science fiction. What we want to do is to bring that habitat as quickly as possible before the end of Artemis on the lunar surface. And in order to achieve that, we need to make sure we fit into the mass constraints of this kind of robotic land. So we had also another budget from BPI here in France that allowed us to build a second habitat based on that new geometry. You can see it here. That was quite nice because we were actually invited by the presidents of the French Assemblée Nationale, Mrs. Brown-Pivet, to expose that habitat together with CNES and Ariane Space in the Assemblée Nationale in France. So these are the pictures, which are quite funny, and it stayed there for more than 1 month. And actually, we want to use that station now as a platform for analog trials. We want to bring it to many places and try different subsystems inside there. I won't go into detail. Our deadline is 2030. EuroHub needs to be on the lunar surface in 2030. Before 2030, otherwise we are out of Artemis. As I said, I don't want to go into detail. That shows a little bit the roadmap, and we are still on track. But the critical moment is coming now. Either Europe is investing in this kind of concept and the technology, or we might be observers in what's happening on the moon in the future. But technically, it's still feasible. And here I come to the last point of my presentation. I said I also want to talk about technologies that is coming back from the moon, if I might say, to Earth in order to address terrestrial challenges. This is very important for 2 reasons. First of all, because I think we have to develop things that can also help to address challenges on Earth. And secondly, as a startup, I must admit, especially in Europe, if you're going around saying you want to sell habitats on the lunar surface, you might have difficulties finding investors. So we are working actually on a concept of technology coming back, and this technology has a potentially higher market than the moon. We have identified 3 elements here. Energy management, as I mentioned already before. I think it's a little bit, unfortunately, the same everywhere. There's an energy crisis right now, so this is quite interesting. And actually, the idea is to produce and store energy as close as possible to the end user. If your energy that you use in order to cook your food comes thousands of kilometers away, there are huge losses. And if the more closer you can produce it and store it, the better it is. Water recycling, we are working on water recycling. We need that obviously for a habitat. There's a lot of water that can be reused, that needs to be reused. And we think that this same technology can come back to Earth. If you just imagine how much water, fresh, drinkable water you are wasting with every time you flush the toilet, this is just crazy. And there are technologies that can be brought back into normal households like. And then the third one is CO2 reduction. Obviously, we need to work on that on our habitat because, as I said, we won't have a habitat that can live for zero emissions. And I do not pretend that this technology can be scaled up immediately in order to reduce the CO2 on our planet. But there might be some technologies coming out that can help to address the problem. Right now, we are mostly targeting the energy management. Again, sorry for the French slides, but basically what we are working on is, as I said before, we are working on regenerative fuel cells that can be used on one side to generate energy out of hydrogen and oxygen. That energy previously was pumped in there by electrolyzing water, and when I produce the energy, I get water out. And obviously, this is a very, very nice system for our lunar habitat. I play with elements that are super interesting: water, oxygen, and energy. But we also think that this kind of technology can come back to Earth. You could imagine something like that on a terrestrial household. We are right now developing a system like that together with our partners that can do exactly the same thing. And while I might not need in a terrestrial household oxygen, I will need energy, I will need water. And so it's also an interesting system for terrestrial application, and we want to develop that on a terrestrial scale. We want to combine that with artificial intelligence. Why? I showed before the schema how energy is used in EuroHub, so we need something like that in order to make it most efficient. That's really also the idea of the energy management. And artificial intelligence will help us to predict several things. How the energy is used in a household. Might it be an astronaut, or might it be a family that's only coming on the weekend into this house? Or switching on the washing machine every morning at 5 o'clock. I have no idea. Something like that. And on the other side, by using data like weather and things like that, we can predict how much energy we can produce. And by doing this, playing together, you can manage the energy more efficiently than before in order to use as little energy out of the grid. So we are working on that system. It's called Refuse, which is maybe not a very good name, but so we want to develop that for EuroHub and also for the terrestrial application. So by that, I have finished my presentation, hopefully not too long. I do not want to finish this before reminding and honoring our co-founder and friend, Jean-Jacques Favier, who was one of the heads behind Spartan Space and EuroHub, and who unfortunately passed away just some months ago. Yeah, he was a very good friend and inspirator for us, and I wanted to put that here. And by this, I have finished my presentation with the last French word in my presentation, which is merci. Yeah, and if you have questions, feel free to ask.
Yeah, thank you so much for this. Could you stop sharing the screen then?
I can.
Yeah. Okay, thank you so much for this interesting lecture. It was really very, very interesting. And I have to apologize that I had to talk so much at the beginning. And I want to mention that we have people watching from the metaverse Africa, from Germany, from Portugal, from UK, and yeah, and other countries. And I have also some questions for you. The first question is from Germany. Are there any estimates on a permanent human presence timeline for the moon? And how many astronauts would be needed to keep that running, maintained?
Okay.
Also,
Yeah.
the habitats, yeah,
Yes.
yeah, genau.
We calculate, our habitat is calculated for a crew of 2 to 4 astronauts. We consider right now a nominal occupation of 2 people inside, but it could go to 4. And this for normally only for some days, maybe 4 days, not more. In a nominal situation, in an off-nominal situation, we can push that a little bit further. But the idea is really having as an exploration base that is only used like a camp, base camp on Everest. You just use it to go further, and you won't stay there for many days. That's not the idea.
But you can use it for emergency cases. This was the next question from Dirk Reiser from Germany. What will be the capacity of astronauts of the EuroHub then? You said it, 2 or 4, and also intended for taking a rest there and sleep, or just to be there for working or eating.
I didn't show it actually, but indeed there are crew quarters inside, so they can stay there for a night. They can work there. There's this glove box that we are developing with IRAP that they could use in order to analyze samples and use instruments in there. But what you said just before, Sabine, is right. You could even just see EuroHub as a live raft. It's just there. They might not need to use it, because they can go much further than 10 kilometers. They can go 30 kilometers with their little rover. If ever there's a problem, they use EuroHub. If there's no problem, maybe they go directly back to the big human landing system from NASA. But it might be a safe haven that is just positioned there, like a little house in the mountain that you can use if ever you get in trouble. And
if the storms comes.
Exactly.
There's another question: are the Artemis missions coordinated with the other nations? And what if China or India or another country ends up in one of the spots before Artemis?
I can obviously not talk for ESA or NASA. I'm just a little startup trying to find its place in there. The question is very good. What if the most prominent case would be China, taikonauts arriving before NASA astronauts on the lunar surface? I do not know what effect that would have. As I said, that's why I said I think the timeline will be respected by NASA, because they want to be the first to be back. Obviously, I just hope this will not put an end to this whole development, and that even if Chinese astronauts, taikonauts are on the surface, NASA astronauts will continue building up a sustainable presence. Because if they don't do that, if NASA is not doing this in the future, NASA and its international partners, then we have just a remake of Apollo. We just do Apollo again, dumping some stuff on the lunar South Pole and not going back for 60 years, and that would be a pity. I really think that we have now the opportunity to build up something. So I hope this is the start of something sustainable on the lunar surface.
And other nations can use this space habitat too in case of emergency.
Yes. That's actually a very nice question, because you have seen there's this kind of airlock, that was this kind of tube that is coming out. I'm a big fan of spacesuits. We have different projects on that, and we were working different spacesuit concepts. Also, with suits that have, for example, a suit port, meaning that you can dock your suit directly to a habitat. There are some American systems that are using this. We did not, on purpose, we did not choose something like that. What we want to have is a system that can be used by Artemis astronauts, yes, but in the case of an emergency, also a taikonaut or an Indian astronaut or whatever can use it without having a specific interface. The idea is really having something that can be used by anybody. So that's why
yeah, it looked like an elevator that opens the door and they can step in and go up, no?
Yeah, they have to climb up. I can tell you, it's a ladder inside. It's
yeah. Okay, and my last question before I give it to the, as the moon has no atmosphere, there can be an impact of some asteroids or meteoroids, and is this kind of protected, or will it be damaged and destroyed?
Well, it depends on the size of the impact, of course. But no, we actually the origin of that concept was a brainstorming, if I might say, with CNES. But it is also based on a project that I had the honor to work on with ESA in the past, which is called PEXTEX, which had as objective to identify new materials for spacesuits for lunar surface. A spacesuit and an inflatable habitat are the same for me. I'm exaggerating a little bit, but basically it's the same. And when we were doing the study, I was working in a previous company, we already said, okay, the same materials for a lunar spacesuit, so being abrasive, being protective and things like that, can also be used for an inflatable habitat. And that somehow later on sparked the idea about EuroHub. So spacesuit materials, yes, obviously you can have an impact that will make a hole. In PEXTEX, we were looking into materials also that have a self-curing capacity, but it's not always technically possible. I think in practice you have to live with a certain degree of air escaping that needs to be in the calculation. By the way, we do not intend to have that habitat inflated all the time, which we would deflate it when it's not used, just in order to save air. And yeah, and then if some air is escaping, anyhow, air will be escaping. There's no secret about that.
Bernard, I would like to give you the word because you're our moon expert. Maybe you can answer some of these questions regarding the landing point, if there is a coordination or is there a competition, and you can ask also some questions to Peter Weiss.
Yeah, first I would like to start by saying that, well, thanks very much for a very comprehensive presentation. And it's an example of also admirable how you came from concept and innovation and execution. You know, not only science fiction, hallucination, but really doing things. And but also you have been able to develop it by involving partners. In particular, you mentioned Euro to Moon and some of the space agencies, as well as big industry, but as well a great ability to communicate with your message, but also these beautiful visuals. It looks almost that it exists. So,
yes.
So
it's true.
We are from this. Now I have a question. One little comment. When you mention the connecting ridge, you have to tell people that we discovered it with Smart One. We call it the Smart One Ridge. You know, we monitored the South Polar region, and we really were the first to monitor it over the whole year. And then we could find that even in winter, this rim is well illuminated. So from time to time, call it the Smart One Ridge, in particular to our NASA colleagues. so that they remember that we were the first really to monitor the moon from 2003 2007, and then they had beautiful mission. But now my question is now the next step to make it also an habitat where you could conduct research and show that you can accommodate a crew. So did you, based on some of your studies, do you have a concept with some scientific experiment and some habitation, accessories where you could demonstrate a profile of a mission? And what is your plan? And we would love to collaborate with you. As you know, we made a proposal together. We want to work together. In the meantime, we build an habitat. We have the big one, ICES habitat, that we try to build in Europe. But yes, do you have a concept of what science could be done when the astronauts are there in the shelter, and also when they are gone? So some robotic science, telerobotics, and also how does it work to demonstrate you could operate it? So what is your plan to demonstrate that in the next year?
Yeah, thank you, Bernard. Actually, as you said before, my colleagues and myself, we like very much going quite quickly into the concrete. We like to build very quickly something, and that's maybe also one of our strengths. Actually, you can make wonderful paper presentations, but when you start building hardware, you see the problems and the challenges. The second version that you saw in Assemblée Nationale that we just finished some weeks ago, some months ago, is more functional than the last one. It's not an inflatable; it's simulating an inflatable structure. We still keep the same diameter, but we have chosen not to make it inflatable for different reasons for operationality. But it can be hermetically closed. So we want to test life support systems inside. We are also collaborating or discussing with ESA for tests in the frame potentially with Melissa and technology like that that we find very interesting. But we want now to populate that system with life support elements. Might it be the famous energy management I mentioned, water recycling, Melissa elements, things like that. And the second reason why we have chosen this new architecture, I'm not talking about the dimension, but the way how it's constructed, is transportability. Just to give you an idea, no, I will not mention how much I paid, but we paid a lot of money, for bringing EuroHub to Dubai and back. Simply because the system is quite big. This new system is very compact. It can be very nicely being disassembled and being brought to many, many different analog sites. You know me very well, Bernard, since many years. Yes. I'm a big fan of analog trials. We want to make analog trials. We have discussions ongoing with the Iceland Space Agency and other entities where we could in the future do trials, and we actually would like to try that habitat in different environments with people inside for 2 or 3 days, living in there, coming out and telling us how to improve it. And this is what we want to do now in this coming phase.
What time scale are you planning for that? Is it the next 6 months or
next year?
Do you need? We have a lot of candidate astronauts that we have trained already in moon base and so on. So we could also provide you with experiments and volunteers from Space Renaissance. And
send them to me. I like astronauts.
Okay. We train them in Hawaii as well. Yes. Or in small habitat. Yes, excellent. So yes, a lot of progress, and yes, very, very concrete. And I think that's also very timely.
By the way, it's as I said before, we do not intend to build that habitat all alone at all. We're searching for partners. We have partners for the inflatable. We have partners for the structure. There are many nice companies and entities that have a lot of expertise.
Yeah.
And we are searching for people who come with innovative technologies, who want to test that insight. So everybody is welcome to contact us and say, okay, I have something that could be put in there. Might it be intravehicular robotics or communication or virtual reality, whatever. I'm super interested in solutions like that, and we will do the best that we can do in order to implement it into Europe.
Maybe you can contact IKEA because they are very experienced in packing or and flat boxes.
Actually, we have worked with IKEA before.
But maybe you should think in this box.
We worked with IKEA.
It
Even in a project where we locked some IKEA innovators in some of our base in Utah, also in Hawaii, and they developed some product. But I think that's clearly what is also interesting message from Peter. We are starting to involve also non-space company and new space, and I think that's it's a great innovation ecosystem we can contribute. So you have been also very well appreciated. You've got a number of prizes as a startup in the system, and also Space Renaissance has collaboration with Eurospace Hub, that is a platform that is funded by EU, that is also mentoring some startup, and we got a number of some of our Space Renaissance members or Moon Mars members that have created their companies for the operation, for also some of the technical system or for the instrumentation where we have done tests in the last 10 years. So clearly we should try to see how we can help you. And this all contribute to the big goal of Space Renaissance, advancing so civilian development in space. So thank you. I leave it more space for others to ask, but really congratulations, looking forward to see some of the progress and to contribute to it.
Thank you, Bernard.
Thank you, Bernard. Now, Adriano.
Yeah, I think I have a couple of questions too. Well, I don't know. If I understood, the mission requirements of this habitat is to host 2 to 4 persons for maybe 4 days maximum in case of emergency. So that means that normally they are not used. It's like something like a rest area. When you travel on an highway, you have on the parking area and a small restroom where you can have what you need urgently and so on. I don't know if I had well understood the mission requirements generally.
Yes, you're right. Actually, the ConOps is we are still discussing. You could use it as a safe haven, but ideally, I would like to see people using it also as a science station for short periods.
Yes, however, if they, I think they will be pressurized, of course.
Yeah, yes, of course.
They will be continuously pressurized, or they only pressurized when it is needed?
No, only when it's needed. We would depressurize for the reason of
typically I am arriving with my rover. I need to go inside. I press some button or some command with an interface, and the habitat starts to pressurize. And then I can get in an airlock, I think.
Yes,
of course. And then of course inside I can take away my helmet and have breathable air.
Yes.
And okay, the last question is, we know that lunar regolith is very dangerous because it is very thin, and you can breathe it and get bad effects of that. So will there be a procedure to avoid taking inside
Yes.
regolith? I don't know, some washing procedure or something like that?
No, well, for instance, as I said, I didn't show the interior, but what we have forced any concept on the interior is what we call a dirty section. That is one section where the astronaut is coming in. Once pressurized, is taking away the spacesuit, leaving the spacesuit there, leaving any tools there. We have that implemented in the second one. Inside the habitat, you have like a curtain, and by that we already want to get rid of some of the dust. Maybe not everything, but a majority. What we do want to avoid is that they come back with their complete spacesuit full of dust, their tools full of dust, and bring them in the exactly same air volume as the habitat. So what we have is this dirty section where they leave the dirty stuff, and to keep the atmosphere inside the habitat as clean as possible.
Okay, thank you very much.
I have some greetings from Roxana from Paris. She's watching from Paris. Dennis Alfonso Rivero is also thanking for the presentation, and the Africa VR campus and center is definitely interested in collaborating with Spartan Space project. Maybe Adriano, you can put this in the chat, the email address or the contact from Peter.
Yes, please.
You have it, or can you put it in the chat, in our chat, Peter?
Yes, okay. Better if you put it in the chat here, then we put it outside.
Genau, this would be easier for us.
You want me to put it now?
Yeah, put it in the chat here, in our chat, and then Adriano can forward it to the other chat.
Yeah, sure. I would be very interested in collaboration, especially with Africa. Please contact me. Just a second, I give you my email address. In the worst case, you just go to the website, you will find some email addresses there, and then you can also contact us.
Yes, you can put it in the chat this minutes we do have. You find the chat downstairs?
Yeah, I just found it.
In the meanwhile, Bernard has another question.
Okay, excellent. So
Adriano is putting the email address into the chat, so who's interested in collaborating can contact Peter Weiss directly. And Bernard, thank you, Adriano.
So I had a practical question, because as you know, we have built also now an habitat based on for 4 astronauts for 1 week, and we have shown it now in Padova, and we are going to bring it to Paris for the Science Week for 3 weeks in ENS Paris-Saclay, and then we will bring it to ESTEC. And I was wondering, are you planning to bring some of your habitat to ESTEC, and then we could build a moon village together, and looking at the synergy between a bigger habitat and your emergency habitat, and we have also access to some rover equipment. So do you have also in the philosophy of the Artemis some plan to test it together with other modules? You mentioned as well some of the Euro to Moon activity for in situ resource utilization. I think that Air Liquide and Grenoble are very active there. So is there some plan of having a coordination of some of these equipment and facilities to really test part of Moon Village coordinated system?
Several things. Number one, I would love to come to ESTEC. When I was discussing with the colleagues in ESTEC, they told me they don't have a place for it right now. But I just understand that Bernard, you can help me with that. So I would be very happy to come to ESTEC too. Then yes, we are continuing with Euro to Moon with our colleagues and friends from that association to do tests. We want to. We are right now working on the docking system in order to have a dirty docking system that allows to robotically dock to the habitat. transfer energy in one direction or another, or fluids in both directions. So we're working on this. And this normally we would like to test in similar environment like we did in Luxembourg, not the same size, because Luxembourg was just fantastic. It was enormous, and but it was only temporary. And we are right now discussing mainly also with CEA in Grenoble, potentially to build something like this. Could also be in other spots. Maybe also another location might be in the future, the lunar facility.
The lunar facility in ESC, DLR, of course.
So the thing is, we want to, as I said, our objective is to make as many people and entities participating into that development with their technology and expertise. So this is really an invitation, and make it travel as much as possible to analog sites or to facilities like Lunar, like ESTEC, like CEA, or the CNES in Toulouse, of course. The idea is really, make that habitat live and use it.
Yeah, you know, from mid of October, we are going to open Space Campus NL. That's a campus outside ESTEC, where there will be a number of facilities. And we will have the first building will be our Eurospace sub habitat, because it's available. It's used inflatable for the moment, but it will be great in this time frame of a few months to show it at ESTEC. Yeah. Also to get a lot of feedback from the technical and exploration people. And there is also opportunity from April, indeed, to have a big operation at the European National Center with a lunar facility, which is to be open there. And they have a space for host experiment, and we need to find a really synergy between all these developments.
Yeah, and what you just mentioned, the idea of combining different habitats, I had it on one of the slides when I said I want. We have worked on that. I didn't show it, but we had the idea that you could think about combining these airlocks by tubes that go over the surface. Obviously, you have to respect a certain distance between one landing site and another. Yeah. Or if you can transport them on the surface, this might be closer. But and that would be fantastic. Combining different habitats to a lunar village. That would be. I would be very, very happy to contribute to that.
Excellent. We'll work on that.
Yes. For this, it would be interesting to have a. Wie sagt man dazu, DIN exit and entrance, so that you can maybe develop like a gateway from one habitat to another, so you have not to change the spacesuit or take it off. But for this, you have to have conformized, oder wie heißt es, wie sagt man dazu, does it how to say dass it standardisiert ist. Standardized. Oh, sometimes
interfaces.
Yeah, genau, exactly.
Yeah, but we have like international docking system that was developed for Apollo to use, and we use that on International Space Station. We are going also to think of standard system for gateway and also for surface habitat. And it's a good way to really solve the problem and to show how we handle it when you have different systems that are built by different stakeholders.
Okay, I really thank you, Peter. It was a really, really interesting evening. And as I told you, sometimes it goes a little bit longer. We had a lively discussion because it was a really interesting topic and you presented it very, very well. And I really appreciate it because I'm not an engineer and I'm an artist. So I really like to learn a lot about this topic, and I find it very interesting and exciting.
Sorry, one little point, Sabine.
Yes.
Peter, you need to have a little area in your Euro hub for art exhibition, because that is what Sabine always proposed. we need to go to the moon with science, with exploration, with technology,
Yes,
but
yes,
also with art.
Yes, we need some space for art. Yeah,
Yeah,
maybe we can.
Yeah, and that's actually quite interesting. We had several contacts concerning that. We wanted to link back also a little bit, if I might say, to the history of Spartan, but we also had the idea of exchanging with colleagues in the US about the aspect of art and how you bring symbols into space exploration. Because I totally agree, this is super important. I mean, it's about extending humanity's frontiers, and so we have to bring something with us. And again, if I might, I talk from a European point of view. This is also why it's so important that there's some European contribution to it. That we say also our continent is bringing something into that adventure, and arts and things like that are very important.
Yeah, we have a moon gallery with 100 pieces of art from all the world. We can put it in your hub. We are also showing it in our Exospace habitat, and we plan to launch it on the early lander. So that's something that could be recurrent every time there is a lander robotic. We have a gallery of art, and then when we have the Euro hub, we can have something where the astronaut can interact with the art. That's right.
Yes.
Same, Sabine. If you have ideas concerning that, please get in contact with me. I'm a fan of that. Obviously, we have to respect constraints like mass and volume and things like that. But sometimes it can be very small symbols.
We launched to ISS.
Yes, we can talk. We can
Peter,
talk about this. Yes.
Peter, sorry. I think we will stay in contact, because I believe you could be interested to the 18 SDG campaign and proposal. So I have just put in the chat the link to sign the petition and to add your organization to the coalition of the promoters. Now we are 61 organizations. They are non-profit organizations, they are universities, they are space agencies and companies also. So you will be very welcome if you want to add your company to as one of the co-promoters to work with us, because we made our meeting the 15th of September, but the campaign is just begun. So we have to promote this to the UN Secretariat, to the COPWAS, everywhere.
I would be delighted to
put it here in the chat too. Then he can copy paste it. Bernard maybe lost the connection. I would like to mention that Bernard and Adriano will report on the 2nd of October live from Baku, where will take place IAC Congress. The next IAC Congress will take place in Baku, and Bernard and Adriano will report from this live. And on the 9th of October, Rick Tomlinson will talk about protect and expand the domain of life. I really thank you for staying with us and being part of our discussion. And I wish you all a nice week and a nice evening. And Peter, I thank you for coming, for joining with us, and I hope we will collaborate and we will work together. And thank you, Bernard, Adriano, for joining, and I wish you all a nice evening.
Thank you very much.
Thanks for hosting, Sabine.
Thank you, Sabine. Thank you, Sabine, for your excellent conduction as always. Okay?
Yes. Ad Astra, ad Lunar.
Ad Astra.